Hey everyone, welcome back to class. This week we're looking at Chapter 9, Environmental and Occupational Epidemiology. Here are the key messages from the chapter for this week. Please feel free to read through these at your convenience. Now, most diseases are caused or influenced by environmental factors. We need to understand the ways in which specific environmental factors can interfere with health to design effective prevention programs. So it's more than just doing sports epidemiology research. It's more than just trying to determine why older adults fall. All very important things, but in the big picture, when looking at epidemiologic factors, we need to understand a whole host of different interactions. And every year that I do this course, there is something of interest from an epidemiologic perspective that's occurring. And one of those things right now is the controversy around the use of Tylenol and autism. Most of the medical community does not believe that that is a cause, or if it is a potential cause, what other factors are occurring? Does somebody have a genetic predisposition? Is there other stuff involved? And so it makes understanding the root cause or causes of a disease or injury very difficult. And so it's almost kind of offensive when somebody says something and the entire medical community is going, well, wait a second. It's a little bit more complicated than that. So, environmental epidemiology provides a scientific basis for studying and interpreting the relationships between the environment and population health. Occupational epidemiology deals with environmental factors in the workplace. From your text, Table 9.1, these are environmental factors that may affect health. And I won't read through all of them, but let's take a look at the first row there, psychological. Stress, unemployment, shift work, human relationships. These are potential factors, psychological factors, that may have an impact upon health. And of course, the other ones that you're looking at there probably make sense too. Now, looking at environmental and occupational health field, this includes a large number of specific and proximate causal factors using the concepts described for hierarchies of causes that were presented in the Causation in Epidemiology screencast. The hierarchy of causes in environmental and occupational health are presented here in this next slide. So take a moment to read through these. Go ahead and pause the recording now. Okay, I'm going to assume that you had an opportunity to read through this hierarchy of causes in environmental and occupational health. Why study environmental or occupational epidemiology? Estimates 25 to 35% of the global burden of disease may be caused by exposure to environmental factors. Major health problems are associated with things like unsafe drinking water and sanitation, indoor air pollution due to biomass energy use for cooking and heating, and urban air pollution from motor vehicles and electric power generation. Now taking a look at high burden in low-income countries. Environmental disease burden is much higher in low-income countries than in high-income countries. However, In the case of certain non-communicable diseases, such as cardiovascular disease and cancers, the per capita disease burden is larger in high-income countries. It's kind of an interesting thing. Now, is that because those are diseases of an older age? And if you are, say, from Uganda, which the average lifespan is 69 years, that maybe an individual has passed away because of a sexually transmitted disease or because of malaria, whereas somebody in a first world country could live to an age of developing cardiovascular disease or a cancer that might come on later in life. Children bear the highest death toll, with more than 4 million environmentally caused deaths yearly, mostly from developing countries. Infant death rate from environmental causes is 12 times higher in low-income countries. Now, the concept of multi-causality. In epidemiologic studies of environmental factors, each factor is often analyzed in isolation. However, there are many ways in which environmental factors can influence each other's effects. Multi-causality and a clear hierarchy of causes are often evident. This may explain differences between the results of observational epi-studies conducted in different locations. And I think this is really interesting when we think about epidemiology. Again, for those of us who usually take this class, we're interested in something, a risk factor related to injury or a risk factor for maybe failing to improve from a course of rehab. But epidemiologists who do this day in and day out, they're really having to take into account sometimes massive amounts of information and trying to understand or narrow it down to one cause may not be a fruitful approach. How environmental factors affect an individual also depends on other risk factor exposures and individual characteristics. So, occupational epidemiology often only explores adult populations, 18 to 65. Often, the research is done with males. Some populations may be specific age ranges. For example, what are the typical age ranges for those who do manually intensive work versus those who don't? Environmental epidemiology explores associations between environmental factors and individuals of all age ranges, as well as individuals who are sick. Exposed people in the general population are likely to be more sensitive to such factors than workers in industry. This is of importance when the results of occupational epi-studies are often used to establish safety standards for specific environmental hazards. For example, the effects of lead at a lower exposure, how that impacts children than how it affects adults. And so, if there is something that doesn't affect adults at a certain level, or maybe doesn't affect non-pregnant adults, does a pregnant adult, does a child, are they at greater risk based upon those levels that have been established by those safety standards? Here's an example looking at the lowest blood levels at which effects on health have been reported in children and adults. In adults, you can see the levels are much higher, especially for changes in neurobehavioral function compared to children. So again, it's fascinating and very complicated. Now, main emphasis in environmental and occupational epidemiology has been on studies of the cause of disease. Specific preventative measures to reduce exposures and the impact of occupational health services also need evaluating. Exposure to hazardous environmental factors is often the result of some industrial or agricultural activity that brings economic benefit to the community. The costs of eliminating these exposures can be considerable. This is a little bit older of a headline here, but it's something that impacts certain parts of our country. Here, Kentucky Coal Town is fighting for survival long after the war on coal is over. And so you can make an argument that coal may not be the best resource for or as a fuel, but it is in some of those communities the lifeline. Even though it's a dangerous form of work, even though people may be at risk for developing diseases by working in that environment, when you take away something like coal in a small town, if it is the job, that is the thing keeping that town afloat. What happens to those individuals? Oftentimes individuals who may not have any other training or academic credentials to fall back on. Here's another one. In Mingo County, residents hope tourism will fill in the economic holes left by coal. And then I don't know where things are at these days when it comes to fracking. But again, whenever there is something that is potentially harmful to the environment or harmful to those using it or living in those communities, there's always going to be political battles over its place or its role in society in that area. Environmental pollution is often costly in itself and may damage agricultural land or industrial property as well as people's health. In epidemiologic analyses, health impact assessments and cost effectiveness analyses help public health authorities to find an acceptable balance between health risks and economic costs of prevention. Examples of combined epi and economic analysis demonstrate the potential value of prevention. So, in Japan in the 60s, 3 related pollution diseases, it was calculated that prevention would have been cheaper than the cure for each of the diseases. That's pretty amazing right there. This table 9.3, pollution damage and control costs for the 3 disease outbreaks in Japan. And really, that's kind of a fascinating thing is, and we'll always continually have these struggles probably within our society where people are pitting economic interests versus health and other societal interests. Environmental epi will face new challenges in the coming decades with changes in the global environment. Studies are needed of the health impacts of global climate change, depletion of the ozone layer, UV radiation, and aspects of population dynamics. Probably we could include in there even a modern issue related to the data centers associated with AI. How do they impact the environmental quality in that region? And then, of course, looking at how climate change can impact an area. Here was from a few years ago. I live near Portland. Now, Portland during the summer months, it can get kind of hot at times. We weren't too particularly hot this past year. I think maybe we had some low 90 days. But take a look at this set of data here showing the highest temperatures for each year. And so, yeah, 98, 99, that can happen. Is it common? Well, 1 or 2 times during the summer. But we had a day where we had 114 in Portland, and actually in my neck of the woods, just a little bit east of the Portland area, we got up to 116. And I believe, if I remember correctly, there was a place in Canada during that heat wave that hit 121. Ah, yes, here it is. Hard to comprehend. Experts react to a record 121 degrees in Canada. So this figure here shows a relationship, how climate change can affect health. And so there is an interconnectedness. And this relationship is far more complicated than I understand, but it highlights how one thing, climate change, can have significant impact upon a variety of factors, and ultimately each of these things can have an impact upon human health. Epidemiologic studies on the effects of environmental factors often deal with very specific factors that can be measured quantitatively. Exposure and dose are therefore important in environmental and occupational epi. Now, exposure, this has two dimensions, a level and duration. Some factors can cause acute effects immediately, for example, sun exposure and a resulting burn, or the London smog epidemic, which we'll see on the next slide here. London smog epidemic here, showing the deaths per day in relationship to pollution concentration. Many environmental factors, however, produce effects only after a long period of exposure. For example, chemicals that build up in the body or hazards that have an accumulative effect, like radiation, or my favorite, noise from rock concerts. In epidemiologic studies, estimates of exposure and dose have been used to quantify the relationship between an environmental factor and the health status of a population. So how much one's been exposed is also an important consideration. Does one have an increased risk of cancer after one X-ray, or does it require multiple doses? Figure 9.3, next slide over, illustrates how the exposure increases. Increasing the exposure increases the relative risk of lung cancer. So here's a relationship between asbestos exposure in particle years and the relative risk of lung cancer. As exposure increases, so does one's relative risk. Sometimes a proxy measure of exposure is used. For example, traffic flow per hour in a particular place or the petrol consumption per year as indicators of air pollution exposure. If the environmental factor under study is a chemical, the exposure level and dose can sometimes be estimated by measuring the concentration in body fluids or tissues. This is really fascinating. This is called biological monitoring. Blood and urine are most commonly used for biological monitoring. Other biological tissue that can be used includes hair, nail clippings, and feces. And we see in the parentheses what they might be looking at. But this really got some exposure, for lack of a better word, when the COVID-19 pandemic was occurring. How people were able to estimate how it was impacting a community based upon assessing wastewater. Here's another example. Now, it says monkeypox there in Bay Area wastewater. Monkeypox has now obviously been changed to Mpox. This was this older news article here. Mpox showed up in Stanford's Sewer Coronavirus Alert Network, which is the only group publishing data on the Mpox in U.S. wastewater. So it's a way to kind of monitor the health in a community. Now, if you're interested in doing something involving biological data, you would likely need to partner with somebody who has expertise in collecting and analyzing this form of data. That makes sense, right? We are healthcare professionals, we don't have that experience, but that's where, if you're working ever in a large university, you might be able to partner with somebody if you've got a particular idea. All right, let's pause here and we'll pick things back up with slide 35 in the next recording.